Today we will talk about the integration techniques. So previously we talked about the applications of the integration to find the volumes, right? And most of the time we needed to integrate the standard functions, right? For example, we needed to integrate the power functions, x in the power of n, dx. So its integration is x in the power of n plus 1 over n plus 1 plus some constant, right? Or just integrating the trigonometric functions. So if I would like to apply the integration for the further applications, we need to learn about the integration of the more difficult functions. Okay, so today we're going to talk about the integration by parts. Trigonometric integration. And integration using the trigonometric substitution. And trigonometric substitution. So let's start with integration by parts. So previously we learned about how to take the derivatives if we are given the multiplication of the two functions, right? For example, if I would like to find the derivative of the sine of x multiplied to the x, then what I need to do is I need to take the derivative of the first function, right? Sine prime of x multiplied to the x plus the first function multiplied to the derivative of the second, right? So we know how to take the derivative of the multiplication of the two functions. Now the idea is, so what if I would like to find the integration of the multiplication of the two functions? Sine of x multiplied to the x dx. Okay, so we know how to integrate the sine of x separately, and we know how to integrate the x separately, right? So now the idea is, like the problem is, I would like to integrate their multiplication. I know how to take this derivative. Now I would like to learn how to take the integration of the multiplication of the two functions. Okay, so the idea is, the concept of the integration by parts is, I need to get rid of one of the functions, okay? So we need to eliminate, so this is the objective of the method, okay? We need to eliminate one of the functions from the integrand. Okay, this is the idea. So let's learn about how to do this. So let's say, do you remember, so I've got this rule, right? So u multiplied to the v, where u and v are the two functions of the x. I would like to take its derivative. So we've got the multiplication rule. It tells us, hey, the derivative of the multiplication of the two functions of the x is the u prime multiplied to the v, right? Plus uv prime. So the same as we did here, right? Now let us integrate all the three terms, okay? So let me integrate the first term with respect to the x, the second one, and the third one, okay? In the left-hand side, this integration will be cancelled with the derivation, and I will have just the term u multiplied to the v is equal to the integration of the u prime v plus v uv prime, okay? Now, if my integration is given as u prime v, then I can find this, I can evaluate this by multiplying uv minus the integration of the uv prime, right? So in more familiar way was like if I have the function in the form u dv, right, or in our case it's v du is equal to the uv minus integration of the u dv, okay? Equivalent forms, right? Do you understand how we obtain this? From the multiplication rule to take the derivative, okay? So if my integration is in this form, so if I can see the multiplication of the two functions, not just like u multiplied to the v, but if I can see this as like a, so the first function is the derivative already of something, okay? So here, in our case. So let's consider an example, sine of x multiplied to the x, okay? I see them not just like a one function u multiplied as a v. I need to see them as u prime, derivative of some function, is already multiplied as a v, okay? Is it clear? So let's try to apply this to this example. So the integration of the sine of x multiplied to the x dx, okay? One of the functions I need to take as the v, and another one I need to take as the du, u prime, okay? But here I need to, again, you need to choose which of them you are going to take as the u and which of them you're going to choose as a dv, right? And here you need to remember the objective of the method. Do you remember what we needed to do? We need to get rid of one of the functions, right? I need to eliminate either sine of x, either x, okay? So what I need to choose is the u, so that in the, so you see, so if I choose something for the v, inside in the next integration in the right hand side part, I will have the derivative of the v, right? So what function I need to choose as the v here, so that in the next integration, this v, the v will be like it will disappear. This function will disappear, x, right? In this case, I need to choose v as the x, okay? Well, let me write this differently. So u dv is equal to the uv minus integration of the v du, okay? Which is more familiar for us. So u is equal to the x, okay? And everything which is left will be dv, okay? What is left? Everything, right? So sine of x multiplied to the dx, right? So then I need to put everything to this formula. In this formula, I need additionally du and also the v, right? So what is the v if the dv is equal to the sine of x? Is minus cosine of x, right? Why? Because do you remember? So if you take the derivative from the both sides, in the left-hand side you will have dv, and in the right-hand side you will have plus sine of x dx, right? So if the u is equal to the x, what is du? Dx, right? Now we just need to put everything to this formula, right? So this is equal to the u multiplied to the v minus v du. So this integration is equal to the x multiplied to the minus cosine of x, right? Minus the integration of the minus cosine of x multiplied to the du, right? Do you see this? Dx. Or this will be simply minus x multiplied to the cosine of x plus sine of x plus some constant, right? Because the integration of the cosine is sine, plus sine, right? Okay. Let's do a couple of examples. So let's start from the simple one. So e in the power of x multiplied to the x dx, okay? Again, this form, right? The multiplication of the two functions, and I need to use the integration by parts, okay? So, I mean, we don't use the integration by parts always when we have the multiplication of the two functions, but mostly we can try the integration by parts in order to solve this kind of problems. So let's say I've got the multiplication of the two functions. Now I need to choose which one of them will be u and which one of them will be dv, right? So if I choose as the u the e in the power of x after one integration, right, after one iteration, it will be still, again, e power of x, right? It will not disappear. So what I need to choose as the u is x, right? Then what I need to choose as the dv, everything which is left, right? So e in the power of x dx. Then, in order to apply the integration by parts, I need to find the derivative of the u, which will be du is equal dx, right? And then I need to integrate this, right? Basically, find the antiderivative of the e in the power of x. So v is equal to the e in the power of x, okay? Then this integration is equal to the x multiplied to the e in the power of x, right? uv minus v du. E in the power of x, which is v, du is dx, right? So we're going to have x in the power e in the power of x minus e in the power of x plus some constant. Okay? So sometimes we need to apply the integration by parts even if we don't have the multiplication of the two functions. For example, let's take this function ln of x dx. Okay? So we know how to take the derivative of the ln of x, right? What is the derivative of the ln of x? Is 1 over x. And the antiderivative of the 1 over x, analogously, will be ln of x, right? But now I'm asking you to find the antiderivative of the ln of x, right? So I don't know how to take the derivative, I don't know how to take the integration of the ln of x, but I know how to find its derivative, right? Let's take this as the u, okay? So let's make this the following substitution. So u is equal to the ln of x. Then dv is everything which is left. So what is left? Is dx, right? Then I need to find the du, which is equal to the 1 over x, right? Multiplied to what? 1 over x multiplied to the dx, right? So it is really important that you need to have the dx there. And v is equal to the x, okay? Now this integration will be u multiplied to the v, right? Ln of x multiplied to the x minus v du, right? Minus the integration of the x multiplied to the 1 over x multiplied to the dx, so which is equal to the ln of x multiplied to the x minus x plus the constant. Okay? So if an exam, I ask you, hey, integrate this, and you feel that you need to use the integration by parts, and you've got some answer, is it possible to check whether your answer is correct? How we need to check this? So we need to just take the derivative from the answer, right? And we need to get what kind of function? The same as inside your integration, ln of x, right? So derivative of the answer should be equal to the ln of x, right? So let's take the derivative in order to just check the answer, okay? So what is the derivative of the ln of x multiplied to the x? I need to use the multiplication rule, right? So this is the derivative of the ln of x, which is 1 over x multiplied to the x, plus ln of x multiplied to the derivative of the x, which is 1, minus, what is the derivative of the x? 1, plus derivative of the constant? 0, right? So this is 1. With this 1, they will be cancelled, right? And you will have ln of x. Exactly the function which is under your integration, right? So the answer is correct. So there are some cases where it is difficult to catch the idea what you need to do. So for example, we did this before as well. E in the power of x, sine of x, dx, right? You remember we did this before? So here, we said, okay, so if I have the multiplication of the two functions, then I need to use the integration by parts, right? The problem is we need to choose which of the functions I'm going to choose as the u, and which of them I'm going to choose as the dv, right? So the point, the objective is, if I'm choosing something as a u, in the next iteration, in the next integration, this function will disappear, right? Or at least its power will be decreased, right? For example, if I would have x squared multiplied as the sine of x, it will be still better to take the x squared as the u, even though in the next integration it will be 2x, right? But after one more integration, it will be 2, right? So here, the problem is, if I choose e in the power of x as the u, after one integration, it will be again e power of x, right? It will not disappear. And if I choose the sine of x as the u, after one integration, it will be again some trigonometric function, right? It doesn't disappear, right? And you remember, so last time we did the trick, right? So let's apply the integration by parts here 2 times and try to get the answer, okay? So let's choose as the u e in the power of x, okay? And dv will be sine of x multiplied to the dx. Okay? What is the du then? E in the power of x dx. What is the v? Minus cosine of x. Okay? Integration of the sine is the minus cosine. So this integration will be equal to, so from here I've got the answer. Integration of the e in the power of x sine of x is equal to the uv, which is minus e in the power of x cosine of x, right? Plus the integration of the e in the power of x cosine of x dx, right? uv, this is uv, minus v du, okay? v du. With this minus, it becomes plus, right? Okay. Now, I mean, I couldn't get rid of one of the functions in the next integration, right? But let's apply the integration by parts again to this last integration one more time. So I would like to evaluate now the integration of the e in the power of x cosine of x dx, okay? So again, I'm going to choose u as the e in the power of x, okay? So dv will be cosine of x dx. Then what is du? E in the power of x dx. And v will be equal to the plus sine of x, right? Derivative of the cosine is minus sine, but the integration of the cosine is plus sine, okay? Now, this integration is equal to e in the power of x multiplied to the sine of x, right? Minus the integration of e in the power of x multiplied to the sine of x dx, right? So this part, the first part is uv, the second part is v du, right? v du. Now let's substitute this integration, the answer, to here. Okay? So what kind of answer we'll get? We'll get the integration of e in the power of x sine of x dx is equal to the minus e in the power of x cosine of x, right? Plus what? Plus e in the power of x sine of x minus integration of e in the power of x sine of x dx, right? I've got this equation, and what I need to find e in the power of x sine of x dx, right? So I'm going to put this term, the last term, to the left-hand side, and what I will have is 2 multiplied to the integration of the e in the power of x sine of x dx is equal to e in the power of x sine of x minus cosine of x, right? Then the integration of the e in the power of x sine of x dx will be equal to e in the power of x over 2 sine of x minus cosine of x. Okay? So in the beginning, we wanted to integrate e in the power of x sine of x dx, right? But we couldn't get rid of one of the functions, right? So that's why we did this twice, and we've got this magic equation, which gives us the answer for this integration. Okay?